Hi children, good morning to everyone. Uh, we discuss three more cases. In case of concave mirror, the nature and position of the images formed by the concave mirror. So, three cases already we discussed. Three more cases are there. Totally six cases will be there. Six cases. If an object can be kept at infinite distance, or in between center of curvature and infinity, or at the center of curvature, or between center of curvature and principal focus, or at the principal focus. The last one is between principal focus and the concave mirror. So first three cases we discussed already. The last three cases we are going to discuss. Okay? Just wait. Come on children. So this is a concave mirror. A given section of concave mirror. So we have to draw like this. A given section of the mirror. There is a ball. A football is there. You just take one section of the football, cutting it vertically, so that a part of the football you can observe like this. This mirror is what is called a concave mirror. Or this is the spherical mirror. This is what is called spherical mirror. This section of the mirror is called aperture of the mirror XY, and this is what is called the principal focus, that is pole of the mirror, and whose center lies somewhere here. So the line joining from center of curvature to the pole of the mirror is called, the line joining from center to the pole of the mirror is called what? The principal, that is axis. This is called principal axis. Now this is center of curvature, and the distance from center of curvature, the distance of center of curvature from the pole is called radius of curvature. Now this could be the midpoint. The midpoint will be the focus of the mirror. This could be the focus of the mirror. So these are called nodal points. This is infinite distance, this is center of curvature, this is principal focus, this is pole of the mirror. Fine. Now a straight object is placed somewhere here. A straight object. You see now? This could be a straight object. Object is kept in between, anywhere in between. Center of curvature is C, principal focus is F. Anywhere in between you can place the object. Suppose an object is placed somewhere here. Now see, this is an object. Placed now. We have placed a straight object is now placed like this. OB is a straight object. Now let us construct the image. After placing the object before the mirror, let us construct the image. The first incident light ray is parallel to the principal axis. This is the first incident light ray. The first incident light ray can be drawn like this now. This is the first incident light ray. So here reflection takes place. From here reflection is taking place because this ray is parallel to the principal axis, and this from this point of incidence, so it has to travel through what? The principal focus. It is now traveling through principal focus. This could be the reflecting light ray. This is the reflecting light ray. So another ray is now traveling through center of curvature. Another ray is traveling through center of curvature. Any ray that is traveling through principal focus must render parallel. We can also draw like that. A ray that is traveling through principal focus, so it should be rendered parallel. Any ray that is passing through center of curvature, that is principal focus, you can also draw like this, and this can be converged here. So this is another ray. See now, you can just take like this. That is traveling through principal focus. It is passing through principal focus, and afterwards it is rendered parallel. It is rendered parallel. It is rendered parallel. Now you see, this is rendered parallel. So these are the two reflecting light rays. This is first reflecting light ray. This is the second reflecting light ray. This is the first incident light ray. This is the second incident light ray. A ray that is traveling through principal focus must be rendered, that is, must be reflected parallel to the principal axis. Now these two rays are converging somewhere here. So this could be the image. This could be the image. This is image. Image is an inverted image, real image. So it's a real image. Due to the convergence of these two light rays, reflecting light rays, an image is formed. That image is what? Formed beyond center of curvature. So what is the nature of the image that is so formed? Nature of the image that is so formed is equals to inverted, real, magnified image. Size of the object is OB. Size is OB, and the size of the object is OB. Size of the image will be, that is, size of the image will be I into M. That is IM, of course. So when object is kept between C and F, a real inverted, diminished, inverted, magnified. Magnify image form అవ్వాలంటే distance of the object must be less than radius of curvature. Magnified image beyond center of curvature, beyond C. This is the case. So this is case 1. We call it as what? Case 4, not 1 actually, case 4. This is part. So the nature is what? It's a real image, inverted image, magnified image formed beyond the center of curvature. So whenever an object is placed between center of curvature and focus, OB is placed. So the real inverted magnified image can be formed beyond center of curvature. It can be caught on screen. Because it's a real, it can be caught on screen. See, the distance of the object is what? Less than radius of curvature. Or distance of the object is what? That is greater than focal length. The distance of the object is, this is what is called distance of the object, which is, this is nothing but focal length. This is focal length. This distance will be focal. I think this case is clear. So let us go to the next case. Please note down. Case 4. Next, case 5. So again, you just consider one more case. This is what is called concave mirror. This side is polished. It's polished like this. This will be the pole, and this will be the center of curvature. So the line passing to the center of curvature and principal focus is called principal axis. This is called principal axis, and this will be focus of the mirror, and an object is placed at the focus. Now earlier it was in between, now it is at focus. It is at focus. Same size of object is now placed. This is OB. So this is first incident light ray parallel to the principal axis. The first ray is parallel to the principal axis. This is parallel to the principal axis, so it has to travel to principal focus. It has to travel to principal focus like this. Another ray is incident on the mirror such that another ray is incident on the mirror such that another ray is incident on the mirror such that, see, it must make an angle of 90 degrees. It must make an angle 90 degrees. This is, see here, carefully observe now. This is a ray is traveling towards the mirror, and there on the mirror the ray makes an angle of 90 degrees. Because it is making an angle of 90 degrees, it is now going like this, and it makes an angle 90 degrees there, so that it has to come back like this. When it is coming back, this point should be equal to what? Center of curvature, and this would be the normal for this surface. So it is retracing its path. It is retracing its path. So when the ray is now striking the mirror, makes an angle 90 degrees here, so that it retraces its path. So now, because of that retracel, these two rays are what? Parallel to each other, and the image is forming where? Infinite distance. The distance of the image will be equal to infinity. So this ray is coming back, and this ray is also reflected like this. These two rays will be parallel to each other. So when screen is kept at a large distance, we are able to see an inverted image, an inverted, real, magnified image. But of course, whose intensity will be small, because it is now caught on the screen at a large distance. Since it is caught at a large distance, it has to be taken like that. So please note down. Let us write the case. Case, that is fine. Children, the case is that the object is set when the object is the object when the object is kept at f at f when object is kept at f, a straight object is kept at f, a final real inverted magnified image is seen at infinity. Right? So u value is equals to distance of the object is equals to what? Focal length. If this distance is equals to how much? Now please tell me. Focal length. Distance of the focus from the pole is called focal length only. When it is at focal length, so the distance of image is equals to how much? What is the distance of from the formula, reflection formula, 1 by f equals to 1 by u plus what? 1 by v. This is a formula for reflection actually. This can be derived also in the next classes. Then afterwards we are going to derive the expression also. So 1 by f is 1 by u plus 1 by v. So u value is substitute here. That is 1 by f should be equals to 1 by u. What is 1 by u? 1 by f plus what? U value is f. What is 1 by v? V. That is v. So this 1 by f cancels. So implies what is 1 by v equals to what? 0. Implies, well, that is distance of the image will be what? Infinity. It's taken like this. Image is formed at distance. This is a well-defined distance. Therefore, we can substitute and understand like that. Children, last case. Case number 2. In this case, the image formed is real image. In this case also, it's real image. Previous 5 cases, 3 cases are there. In those 3 cases also, the image formed is a real image. The last case is the most important case. Sixth case. Sixth case we should write like this. This is the given section of the mirror xy. You can just take like this. The polished surface is away from its center of curvature. This is the pole of the mirror. And the line passing through the center of curvature and the pole of the mirror is now taken as like this. That's called principal axis. Now object should be placed in between focus and what? Somewhere here it is placed in between focus and pole of the mirror. This is center of curvature. So now what is going to happen? You see here. So here the first incident light ray is parallel to the principal axis according to the rules for the construction of the image, and therefore it must travel through principal focus. It is now traveling like this. It is traveling like this. See, this is an incident ray parallel to the principal axis, and after reflection, the reflecting ray is traveling through principal focus. Another ray you have to consider that has to. So it is now one more ray you have to consider now like this. One more ray you have to consider like this. You see, it is now incident like this. See, it is incident like this, and it makes an angle 90 degrees with the surface of the glass, surface of the mirror. Therefore, it is now retracing back. It is going back like this. While going back, it has to travel through center of curvature. It has to travel center. So our eye will be here somewhere. Our eye will be here. So when we observe the eye, this is in the field of view of these two. That's when we observe. We feel as if the rays are coming from here. We feel as if the rays are coming from here. This is also. See here. We feel as if the rays are coming from that point. Dotted lines. It must be denoted by dotted line. And these two rays appear to be coming from here. So the image that is so formed must be a virtual image. The virtual image must be drawn like this. This is a straight image. All virtual images are straight. This is a virtual image. Virtual. This is real. This is real. This will be real. This is a real image. This is what virtual image. It's a straight image. All virtual images are always straight. It is a straight image. So when we look from here, so we are able to see the image. This is a virtual image. So in this case, so what shall I write? When object is, case 6, when object is placed within the focus, placed within focus, a virtual straight magnified image can be seen on the other side of the mirror. Side of mirror. Okay, children. These cases you should practice and remember where exactly the image is found, where you are going to place the object. So position of the object you must understand, and position of the image and its nature also you should understand. Thank you.